Okay, let's make a context-free grammar for the set of all strings that are not of the form A to the n, B to the n, C to the n. So the uncomplemented version of this language is not context-free, but this one is because we're going to make a context-free grammar for it. Well, if a string is not of this form, then there are several conditions in which it could be. For instance, if it has a BA in the string somewhere, then that is not of the form A to the n, B to the n, C to the n, because that requires A's before B's before C's. So if it contains a BA anywhere, then we're good to go. If it contains a CA anywhere, we're good to go. And if it contains a CB anywhere, we're good to go. So let's go ahead and make those. I'm going to have a variable x sub BA handle that there is a BA somewhere in there. Whatever the string looks like, wherever the BA is on either side, then anything, literally anything, can appear on either side of this BA. So let's allow ourselves to spit off as many A's and B's on either side as we want. And in fact, C's here too. So let's do A x sub BA, or B x sub BA, or C x sub BA, or X BA, and then so the A can be generated at the end, or XBAB, or XBAC. And then finally, the base case is going to be BA, the forbidden string that we were hunting for, so to speak. So then now we could, in principle, do the exact same thing for CA and do a similar type thing. And of course, we need to do a similar thing for CB. So I'm not going to write these down, but I'm assuming that these three variables exist. Well, the other way that a string could be not of this form is if it doesn't fit one of these buckets, it must have A's before B's before C's, but one of the counts is off. So it either is the case that we have A to the I, B to the J, C to the K, where I is not equal to J, or J is not equal to K, or I is not equal to K. So let's handle one of them, and in principle, we could do the other two. So let's call it A sub I not equal to J. Well, if two counts aren't the same, we can solve that by saying one is less than the other one, and then union the two cases. So I is less than J, or I is bigger than J. So let's make two variables for those. So AI bigger than J, or AI is less than J. So then let's do the first one. So AI bigger than J. What that means is that we have more A's than B's, but then the number of C's, I don't care, as long as the number of A's is bigger than the number of B's. So notice that we need to have an equal number of A's and B's and then have more A's on top of that. So let's spout off an equal number to start with, I bigger than J, B. And then we need to have another variable be able to handle adding more A's than that. So let's call it x sub A, allowing ourselves to make more A's. And x sub A is going to have a base case of a single A, or allowing ourselves to make more A's. But this is not quite the solution, because right here we're saying that this B is at the very end of the whole string, but that's not the case. We're allowing ourselves to have some C's at the end of that. So the way to fix that is to not do this, but instead have another variable where this AI bigger than J thing is going to spout off some C's, any number, and then as the base case, go to that other variable that does the thing that we just did. So let's allow ourselves to make as many C's as we want at the end specifically, because that's where the C's are. So that allows us to make as many of those as we want, a bunch of C's at the end. But as the base case, we need to go to a different variable. Let's call it I bigger than J, comma 2. And then that one is going to do the work that we just did. So let's go ahead and write that down. So I bigger than J, 2, with a B at the end. And then go to the XA variable that we just did, which spouts off one or more A's. So that handles this one. This one is incredibly similar in that we will do the same trick we had here of spouting off some C's at the end, but then the base case would be a variable of the form x sub B, which is going to spout off one or more B's. And then the other two cases are incredibly similar. The only different one is I not equal to k, because there, the one which doesn't really matter in terms of count is in the middle. And so therefore, we would need to split it off into having the base case being make as many b's as you want. And instead of having to do this, you have to rearrange the variables somewhat. But I argue that it's not that much different from this. So that was a context-free grammar for the set of all strings that are not of the form a to the n, b to the n, c to the n.